Section 8.5 is quadratic equations, difference of two perfect squares. When you have a binomial that has a minus sign in between, and the first term is a perfect square and the last term is a perfect square, what you're missing is the middle term. Right here. You don't have that. And it's a minus sign in between. That's called a difference of two perfect square. And they factor into opposite binomials. So you make your two binomials. Think of this minus as the very last sign. So when the signs are different, when the last sign is negative, the signs are different. Factors of x squared are x and x. Now we're going to use the perfect square. Square root of 25 is 5. So 25 is a perfect square. If you'll notice, if you did the entire FOIL method, we get x squared, then your outside term is a negative 5x, your inside term is a positive 5x, and your last is a negative 25. Your two middle terms go away, so you get x squared minus 25. So these are the easiest ones to factor. They're called a difference of two perfect square. So if the first term is a perfect square and the last term is a perfect square and it's a minus sign, it is a difference of two perfect square. The factors into two of the identical binomials except the signs are opposite. One's positive and one's negative. Here are the list of the perfect squares. You will need to at least have the first 15 memorized for a problem on a daily quiz. You need to have them memorized. Like 4 is the perfect square. 2 is not the perfect square. 4 is. 9 is the perfect square. Square root of 9 is 3. Square root of 16 are 4. So all of these numbers are perfect squares. So write these down in your notes. Example 1C. 16 and 9 are both perfect squares, so that factors into 4h plus 3a times 4h minus 3a. D, that's backwards, but we can still factor it backwards. That's 11 plus 2b times 11 minus 2b. Example 1e. 81 minus c squared, that's backwards, but let's leave it backwards. 9 plus c times 9 minus c. F, that's 8g plus h times 8g minus h. G is 3x plus 7 times 3x minus 7. H, that's 4x plus 9y times 4x minus 9y. To factor and solve, before you can factor, you must put equal to 0. So I'm going to have to subtract the 36. Now that is a difference of two perfect square that factors in 2x plus 6 times 2x minus 6. Take each binomial out of the parentheses and put them equal to 0. Subtract 6. I have two equations to solve. Divide by 2. I can do that in my head and get x is equal to negative 3. And I get x is equal to, oh, that's a positive. Aren't your negatives? Okay, example B. That is a perfect square. 1 throws people off. 1 is a perfect square. 1 times 1. So that's 5x plus 1 times 5x minus 1. So 5x plus 1 is equal to 0, and 5x minus 1 is equal to 0. Subtract 1 on both sides. Divide by 5, so x is equal to negative 1/5. Second equation, add 1, divide by 5, so x is equal to positive 1/5. Section 8.6 is quadratic equations with perfect squares. Now we could have a perfect square trinomial. If your first term is a perfect square and your last term is a perfect square and the signs are, and the last sign is positive, then it could be a perfect square trinomial that factors into two identical binomials. A plus b times a plus b, or you could say a plus b quantity squared. But these you have to check because they might trick you and not get you the middle term. So, this example, that's x plus 4 times x plus 4. But again, you still have to check. That's a 4x, and a 4x gives you 9x. And you can do a quick mental check. The signs are the same over on this trinomial, so that's x minus 3 times x minus 3. Check, that's negative 3, and negative 3 is negative 6. And you could go one step further and write x minus 3 quantity squared if you wanted to. Example 3, that looks like a perfect square trinomial. First term is a perfect square, last term is a perfect square. The signs are both going to be positive. So that's what I'm going to go for first. X plus 4 times x plus 4. Now check. 4x and 4x gives me 8x. That is not my middle term. So I have to do it the long way. List the factors of 16. Now which factors of 16 add up to get 10? 2 and 8. So it looked like a perfect square trinomial, but it wasn't. So you always have to check. Example 3b, I think it's a perfect square trinomial, so I'm going to try. 4x and 4x is 8x. Yep, it is. Example 3c, I think it's a perfect square trinomial because my first term is a perfect square and my last term is a perfect square. You need to have your perfect squares memorized. So I'm going to try that route. The signs are the same, so that's 4x minus 3 times 4x minus 3. Check, that's a negative 12x. And a negative 12x is a negative 24x. That is my middle term, so it is a perfect square. If you want to write 4x minus 3 quantity squared, that's fine. Example D, I think it's a perfect square. 4x minus 3 times 4x minus 3. When I do a check, that's negative 12, and negative 12 is a negative 24. That is not my middle term. So I am going to have to do it the old AC method or guess and check method. I am going to list my middle terms of 9. 1 times 9. Obviously, the 3 and the 3 did not work, so I'm going to try the 1 and the 9. My outside is a negative 36, and my inside is a negative 40. Negative 4, which is a negative 40. That does not work. So I'm going to try the 16 factors of 16, 1 16, 2 and 8, or 4 and 4. The 4 and the 4 did not work, so I'm going to try the 2 and the 8. That's a negative 18, and a negative 8 is a negative 26. That didn't work, so I'm going to switch the 8 and the 4 around. Or, this is getting a little too complicated, I am going to do the AC method, splitting the middle term. So as long as I have a calculator, I'm going to multiply 16 times 9, and I get 144. Now, playing around with your calculator, you have to find factors. The signs are going to be the same. So what factors add up to get 30? Okay, I found the factors that add up to get 30, 6 and 24. So I am going to split my middle term, and it really doesn't matter which one is first, 6x, negative 6x, and negative 24x plus 9. Group my first two together. That negative has got to go inside. Group my last two together. I am going to factor out a 2x, and I get 8x minus 3. And I'm going to factor out a negative 3, and I get 8x minus 3. So now I'm going to factor out the 8x minus 3. They become 1 times 2x minus 3. So I would have eventually gotten it doing the guess and check method. And that is the end of these two sections.